here's a video on the 5B review part. Number 1. This right here, if you remember from back early in our earlier days, means simply plug in -3. So you can get that answer just by plugging in -3 for all the x's as a check. So you can run that as a check to make sure you get the right answer, because this says use synthetic process. So this looks to me like I got 27 or minus 27 plus -6 minus 5. Looks to me like I should get -11. Okay, so I'm looking for -11. So how do I evaluate P of -3 synthetically? I put the -3 on the outside. I put my coefficients on the inside, noticing that the degree is 3, so I need 4 numbers on the inside. Synthetic process, drop it down. Multiply, -3 times -1 is 3, add. Multiply, 0, add. Multiply, -6. Notice -11 matches -11. That last number, synthetically, is the answer. So when I'm talking on a test, you should be doing this work over here. And then in your answer blank, simply saying -11. You're not saying -11 over x plus 3 or anything like that. You're not putting negative x squared. You're not doing division. You're using this to actually come up with a simple value. Okay? Down here, we're dividing. And it says synthetically, make sure you follow directions. So if I divide, and it's got to be a linear when I divide. This is a divide sign, not add. If I divide by x minus 4, I put a 4 on the outside. Again, it's x to the third, so I need 4 numbers on the inside, and they're all accounted for. 1, 2, 3, 4. Well, drop it down to multiply, add, multiply, add, multiply, add. I start with x to the third. I'm dividing by x, so this right here is x squared. X to the third divided by x is x squared. So it's 2x squared plus x. Minus 3 plus the last number is your remainder, 1 over the divisor, x minus 4. Over here, I'm divided by x minus 2, so I put a 2 on the outside. It's to the 4th, so I should have 5 numbers. There's only 3 here, so there's some missing spaces. It's 1x to the 4th. I don't see an x to the 3rd. -3x squared. I don't see an x. And then -10. And then just do the same thing I did on the left. Drop the 1 down, multiply, add, multiply, add, multiply, add, multiply, add. Start as x to the 4th, so this is x to the 3rd. Just work your way down. 2x squared plus x plus 2 plus, I would do plus and negative here. So we save. The 6 goes over x minus 2. That's synthetic division. Long division. This one you can actually do synthetically, but I'm telling you to do it by long division. So make sure you use long division. So 3x plus 1 goes on the outside. I don't see any gaps in there. It should have 4 terms because it's to the 3rd, and there are 4, so I don't need to put any spaces in there. And it's all about the first term. You want 3x to look like 3x to the 3rd. 3x to the 3rd divided by 3x is x squared. I'm going to be multiplying x squared by the divisor to get 3x to the 3rd, and then I'm also going to get x squared. Switch the signs. Add straight down, x to the 3rd's gone. I get -6x squared plus 10x, bring the other stuff down, minus 3. It's about the first terms. I want 3x to look like -6x squared. -6x squared divided by 3x is -2x. So I'm multiplying -2x by the divisor. That gives me that -6x squared I was looking for. It also gives me -2x. Switch the signs. X squareds go away. I get positive 12x minus 3. Got to keep going until the degree on the bottom is smaller than the degree over here in the divisor. They're the same, so keep going. 12x divided by 3x is 4, positive 4. We take 4 times 3x plus 1. Gets me 12x plus 4. Switch the signs. X's go away. I get a remainder of -7. Bring that up here, put plus -7 over my divisor. There's the answer. Number 5, the product of 3 consecutive integers is 210. Write the polynomial equation. So I'm going to have f of x equals or something like that because it says equation in factored form and solve synthetically to find the numbers. Okay, it does say factored form. I'm going to have you multiply those out, but I want 3 consecutive integers. You need to call, so I got like a first, second, and third number basically. You need to call one of them x. You could call the first one x, in which case the next one will be 1 bigger, x plus 1, and the next one will be 1 bigger than that, x plus 2. I mentioned that it's actually easier to let the second one be x, so the third one's actually 1 bigger, and the first one's 1 smaller. That way, when you multiply them out, you're multiplying conjugates. So the product has to be 210. This is actually factored form, but if I want you guys to multiply these out. So when you multiply x plus 1 times x minus 1, those are conjugates. The middle goes away, so you're going to get x squared minus 1. Right, x times x and 1 times -1. Distribute the x. You get x to the third minus x equals 210. So just minus the 210 over, set it equal to 0. And that's where you're going to use your calculator to find out what makes it equal 0. Get my calculator to come forward. There we go. All right. Clear all this stuff out of here. All right, so what am I typing in again? I got x to the third minus x minus 210. X, caret, third, arrow to the right, minus x minus 210. Zoom 6, see if it shows up there. And it does. Looks like it's 1, 2, 3, 4, 5, 6 to the right. If it didn't show up there, you can expand your window out. Or if you go to second graph, you can just arrow up and down and see where it hits 0, and you can see at 6 it's 0. Right? And then as I go bigger, it's actually growing again there. So 6 is 0. That's my x. I know x is 6. I want you to verify that synthetically on the test. A lot of points on the test, so verify that synthetically. So we got 1. There's no x squared term. -1, -210. If you're verifying it correctly, you're going to end up with 0 at the end. 6 times 35 is 210. You get 0 at the end. It works. I'm not worried about these other 2 answers you get from x squared plus 6x plus 35. I just want you to verify 6 works, and that's my x. Therefore, x plus 1 is 7, and x minus 1 is 5. You got 5, 6, 7. Got to show your work. Trial and error is not going to be rewarded on the test. Okay? Number 6, rational root theorem. What numbers could you try? You need to use the lead coefficient and the constant term. Put the constant term first, lead coefficient second. Find those factors. Factors of 7 are 1 and 7. Factors of 6 are 1, 2, 3, 6. And then your possibilities are plus or minus, funky bracket. All the factors of 7 over each of the factors of 6. So I got 1 over 1, 7 over 1. I got 1 over 2, 7 over 2. Got 1 over 3, 7 over 3. And 1 over 6, 7 over 6. Those are all your possibilities. So it looks like there's 16 different numbers you could try synthetically along with this to see if you can find something equal to 0 at the end. Okay. And finally, number 7, find all the zeros. Hopefully you know that your zeros are going to be factors of 72. If I wrote down my possibilities. I'd have 72 and 1, and so there'd be factors of 72. But we're going to use our calculator. So I can locate my calculator again here. Y equals, I want x to the fourth, x caret 4 plus x to the third minus x squared, yep, minus x squared, minus x squared, minus x minus 72. Verify I did that right. Oh, minus 9x, not x. So I forgot to put a 9 in there. All right, so I can go over the x, and if I hit second delete, it allows me to put the 9 right in there instead of having to retype over everything. All right, I got Zoom 6 going on here. Looks like -3 is a 0, and it looks like 3 is a 0. Second graph, look at the table to verify. 3 is a 0, arrow up. And -3 is a 0. So those are the two I'm going to use. There are 4 answers because it's x to the fourth. I'm using 3 and -3 for my calculator. 3 does go into 72. It's a factor of 72, so I could have gotten that if I'd have listed my possibilities. I'm going to start with 3. I need to have 5 numbers on the inside because it's x to the fourth. There are 5 terms, so I don't have to add anything in there. Better be 0 at the end. If not, I made a mistake and I need to locate it. Multiply, add, multiply, add, multiply, add, multiply. Put 0 at the end. I want to get down to a quadratic. This is a cubic. Because it started as a quartic. So I'm at a cubic, so I got to go again. Put -3 in. Drop it down. Multiply, add, multiply, add, multiply, add. Now I'm down to a quadratic, x squared plus x plus 8. That is not factorable. I can't multiply to be 8 and get 1. So I'm going to have to do my good old quadratic formula. X equals -b plus or minus square root. B squared minus 4ac all over 2a. -1 plus or minus. The discriminant is 1 minus 32, -31. Over 2. And the square root of negative, so it's an I, so you can write it as -1/2 plus or minus square root 31 over 2 with an I. And don't forget you had plus or minus 3 as the answers that were rational. So you got 2 imaginary answers and then 2 rational answers to get you the total of 4 that this thing had. So hopefully this was helpful for some of you. Get all studied up and ready for our test. Wish you all the best. Have a great day.